Good. So, yeah, I came to Singapore actually to tell stories, apparently. So yesterday I was telling the story about the yellow runtime, and today I'm going to tell you the story of IPC from what was the past, what's the present, and what's the future. So let's have this random walk on IPC. So at Juan mentioned yesterday, like the IPC idea has been there in his head since the early days, but actually when we started implementing this, was like 2 years ago, where we started figuring out what were the mechanics at a high level of the system, and we published this paper and an MVP over Lotus, a monolithic MVP, where we tested. Actually, there was no FVM then, it was just the legacy VM, and we implemented everything over Lotus with the legacy VM, figuring out like atomic execution and how all of the prototypes of all of the primitives that we needed for this horizontal scaling. And our proposal, as Mark already mentioned, is to have hierarchical subnets. So to have a recursive system that would allow us to have these sidechains that connect to each other with these by default and by design cross-net primitives. And it's all governed by a bunch of factors, as Marco mentioned. So in 2022, we had these MVP, and the kind of features that we tested in the MVP was like the whole end-to-end that we felt that it makes sense for subnets, from the life cycle of a subnet, so how we deploy new subnets, how we kill subnets, how collateral will work, all of the interactions and so on. We also tested it with a fast, high throughput new consensus protocol. I mean, not new consensus protocol, but like an improved consensus protocol that our team built. That was this Mir Trantor protocol. It's a BFT protocol for subnets, high throughput. Like we recently benchmarked it, and it's in the order of like the half, like 5,000 to 10,000 transactions per second, with around 1 second finality and latency. So this was the MVP where we tested like the end-to-end over Lotus, and this was the project Eurico. We even wrote a FIP proposal, because then we were thinking about like embedding this as part of the Lotus client directly and like make it part of native Filecoin. But then like things started to change in the Filecoin ecosystem, and as I mentioned, like all of this was a set of spec actors in the legacy VM. But as we moved forward, we had to switch from the legacy VM to the FVM, and this was the next milestone in IPC. And here what we did is that all of these spec actors, they became native actors for the FVM, so written in WASM, compiled to WASM, and native into the FVM. Because our idea was still for these to be system actors that were deployed over Lotus and over the Filecoin network. But we kept, like, things kept changing, and as we were moving towards production, we realized that we may have in the future several runtimes, and we may have several client implementations. And that's how we reached our first testnet milestone, in which we had Lotus, we had this Mir Trantor, and we have this IPC agent, which is this piece of software that allowed us to orchestrate the different peer implementations with subnets. So we had like the peer implementation for subnets, and we have the IPC agent that was orchestrating the messages between them. So we moved from Lotus, legacy VM, and so on, to FVM, to a more modular infrastructure with FVM and the IPC agent to orchestrate everything. And we were starting like moving into production in this way. And that's how we reached the SpaceNet milestone. SpaceNet that actually was deprecated yesterday, and I will tell you why. Because now we can have calibration, like we can test everything in calibration, so it makes no sense to have an IPC-specific subnet. So the reason why we had like this testnet for a while was to let developers start testing IPC with fast block times and also these native factors, because I mentioned that all the IPC logic was in a set of contracts that were targeting native FVM, because we thought that IPC was going to be run over built-in actors. But then when FVM started to move into user-defined actors and FEVM, it made no sense to keep like the built-in actors and have to be privileged actors, when actually we could let anyone run their own and customize their own IPC and their own subnet actors. And that's how FEVM was released. we all know FEVM, but that meant that we needed another change to the protocol because like before we had WASM actors, they were privileged actors in the system bundle, but we had to move into the FEM. If we wanted like IPC to be used in userland, we had to write the Solidity contracts. So that's why we moved from the legacy VM to the FVM native actors to finally the Solidity actors, which is the current state. So right now, the contracts that are governing IPC, they are Solidity contracts that are deployed in userland into, in our case now, calibration or mainnet, but like it, as Marco mentioned, they could be deployed over Ethereum. And what are the kind of features that we can use right now with IPC? So we have the same that we had in that original MVP. So you can deploy your Mirror Trantor subnet, you can deploy FEVM contracts and like deploy your application over a fast finality high throughput subnet so that you don't have to pay all of the performance penalty, let's say, that the mainnet has. And we have the basic crossnet transactions. So these top-down and bottom-up transactions that, that Marco was describing before. And if we want to deploy a subnet, what are the steps that we need to follow? And we want to have a workshop afterwards where we're going to showcase all of this, but like in the current state, and like I'm stressing the current state because right now everything is Lotus-based, FVM, Solidity, and we have this APC agent. But we are trying to move forwards, and one of the goals that I have for this session and like the workshop is to gather as much feedback as we can. So because if we move from, you see that like the protocol has suffered a lot of changes because of how the stack has evolved. And we had to have a lot of like compatibility into all of these paths, and it would be really useful to get a feedback on like what would be useful for you as either subnet operators or application developers to make this as seamless as possible. But to give you a sense of what is required right now to deploy your own subnet, first you need to deploy the IPC agent daemon, which is a process that is going to be the one that handles and orchestrates all of the underlying communication with the different subnets. Then you need to deploy the subnet smart contract. So we have a reference implementation, but you could deploy any smart contract that determines the policy and the logic governing your subnet, and then you just deploy the subnet infrastructure. And with that, through the RPC API of the subnet, you would be able to deploy your smart contracts into the subnet and start using all of the IPC primitives and like have this high throughput subnet for your application. Unfortunately, like this is not good enough. We've realized, like interacting with the users, this is rough. The fact that we're using Lotus makes it like less reliable because of how we are integrating this high throughput consensus and so on. So that's why we needed something more. So the current state, what we have is an integration with Mirror, Trantor, and Lotus that is not reliable because, like as I was mentioning yesterday, Lotus is architect for a longest chain protocol, and this high throughput consensus is a fast finality, so it requires another way of integrating the consensus into the peer implementation. The fact that we need the IPC agent is a bit inconvenient because it's just an additional process that you need in order to run a subnet. There are a lot of UX improvements that we can do. The configurability of the client implementation can be improved. There's a lot of technical and design debt because of all of these changes into the scope. So that's why like the current milestone wasn't enough, and we are trying to release, and we are completely reworking the stack. And how are we reworking the stack? This is the next milestone that we're going to release in a few weeks, and it's that we're moving from Lotus-based subnets to Fernermin-based subnets. Because I was mentioning yesterday that Lotus is great, but it may not fit our needs for this fast finality, high throughput use case. But fortunately, like there are already a BFT protocol and like Comet BFT as a Tendermint framework in order to run this kind of consensus. So what we're doing is that for the last year, we've been building in parallel to Lotus a new client based on this Comet BFT, which is a Tendermint framework, with FVM and IPLD, so that we have a peer client with all of the bases on top of an existing out-of-the-box consensus, so that eventually we can replace it. And it is completely written in Rust. So we shifted completely from a Go-based code base to a Rust-based code base. The next thing that we're doing in the next milestone is that we're removing the IPC agent. So instead of having like this process that needs to govern, because before in Lotus, if we wanted like system actors, if we wanted to embed into the client, we couldn't change much without going through a FIP. So there was a limit on what we could do into mainnet. But now that we have our own peer implementation, a lot of the processes that were governed by the IPC agent, now they can be embedded directly in the Fendermin client, which allows us to have a better UX and also remove completely the need of the IPC agent. So hopefully with this, we're going to improve the UX and the reliability. So we're shifted from this Lotus like constrained environment to one where we control more and we have an out-of-the-box consensus. And we're moving towards like this modular setup and architecture that I was mentioning yesterday in the yellow runtime. And like the goal, this is not the case right now, as you'll see in the workshop, but the goal is that deploying a subnet should be as simple as saying IPC CLI subnet deploy and make deploy subnet to deploy the infrastructure, right? So this is the goal that we're after, like simplifying the UX and making a stack that allows us for a subnet operator to have this kind of interaction with IPC. And as I'm going to showcase in the workshop, like Fendermin is close to be ready to be taken for a spin. So Fendermin is there. Like we have already the client implementation. We're going to deploy a bunch of smart contracts there and see how it works. But we still need a few weeks to integrate it into all of the IPC hierarchy and like have it as a child subnet. So I'm going to showcase like what is the case today with Lotus-based subnets, but I'm also going to glimpse how it would work with Fendermin because we're really close to release the ability of having Fendermin-based subnets. And then to finish with this, I don't know if there are questions, like we're not many in the room, so just feel free to interrupt me and ask questions, don't wait for the end. And here, like, I want to interact more with you because, like, what I'm going to cover is some of the frequently asked questions that everyone asks around IPC. So, because, like, IPC is these fuzzy concepts with a lot of moving pieces, and sometimes it's really hard to grasp what it is possible and, like, what is the interaction and the UX with the system. So, what I would love is, like, to share what are these frequently asked questions that people usually ask me, and, like, for you to ask your questions or, like, jump in, chime in if you see that you can give us feedback with things. So yeah, this is like the $1 million question, like smart contracts in subnets. Can I deploy my smart contracts in subnets? The short answer is, of course, you can do as much as you can do with any other EVM network. Because as I mentioned, now we are running FVM, both in the Lotus-based and the Fendermin-based subnets. We are running FVM with FEVM enabled, which means that you can deploy your FVM Solidity contracts. You can interact using the ETH RPC, so anything that you can do in Lotus and in any other EVM-compatible network, you should be able to do it in a Fendermin-based and Lotus-based subnet. With an additional caveat, which is that with Fendermin, and actually in Lotus, but it's a bit harder in Lotus, but with Fendermin, we are enabling a way for you to deploy privileged actors or like to build your own bundle for the subnet. Which means that, imagine that, and this is a real use case. So Tableland, for instance, they're trying to build their decentralized MySQL over a subnet, and they need to have WASM actors. But WASM actors doesn't exist yet in the FVM in a user-defined domain. So it means that on a running environment, you cannot deploy a WASM actor. But with the Fendermin-based and also our Lotus-based subnets, we enabled a way in which you can build your own custom bundle, introduce your privileged WASM actors, in the case of Tableland, this SQL contract, and be able to deploy it as if it was any other contract. It has some problems with upgradability and so on, but like at least to showcase that the flexibility that subnets will give you. Like the idea is that eventually, and as we move into this yellow runtime ideal, we should be able to deploy any kind, like configure and fine-tune the subnet to whatever you need. So to the answer, like smart contracts in subnets, is this a thing? Yes, of course. This is like a requirement for subnets. And you will be able to do whatever you can do today in Lotus and other EVM chains. And how is a subnet deployed? We're going to see this in a minute, but the idea, like the basic flow is the following. Like, remember from Marco's description that every subnet has a contract in its parent that governs its policy, right? So that determines the rules, like what is the minimum number of validators, what is the amount of collateral that it needs to become a validator, what is the consensus. So there are a lot of rules there that are governed by a contract, a subnet actor or subnet contract in the parent. So in order to deploy a smart contract, the first thing that we need to, deploy a subnet, the first thing that we need to do is deploy this smart contract. Second thing, like depending on the number of validators, we need validators to join. And once validators join, we can create the genesis and deploy the infrastructure. So these are the 3 steps that we need to follow in order to deploy a subnet. We deploy the actor, we join as a validator, so we put some collateral, and once the collateral and the minimum requirements defined in the contract are fulfilled, we can deploy the infrastructure to start the subnet. Any question, feedback? Yep, Mika.
I know the answer, but it looked to me like not very clear from the slide. Oh, I have it. So I just want to double check the difference between join as validator versus deploying infrastructure.
Right.
Join as validator, is it just adding a record somewhere on the parent mainnet? It's not really running validator, right?
Right. So all of our subnets are based on a proof of stake, which means that you need to put some collateral. You need to have some stake in order to be able to validate new blocks in the subnet. So that's why first you join. So you put the collateral in order to have validating rights. And then you deploy the infrastructure. Then you deploy your node to start validating. So
join as a validator is actually creating a record that this validator can be run.
It's
and
like,
then you run it.
If we go to the Filecoin setup, it's like we need to pledge some storage in order to participate from the consensus. Yeah. So this is the same approach, but for a proof of stake chain. We put some coins, and then we are allowed to deploy the node and start mining in it.
And my second question is deploy infrastructure complex for Lotus-based. Is it going to ever be simple?
Yes. Not for Lotus-based. We'll see. It would require work. Like Fenderman simplifies a lot of this because we've made the peer implementation to fit our needs in IPC. For Lotus, we need to have a lot of glue code to match the needs of Filecoin and like the needs of IPC. So it's,
I mean for default, for the default stack.
For the default stack, it's going to be easy through Fenderman eventually. Yeah. And we're working towards that, yeah. All right, and then like this is another common question. When should I use mainnet? When should I use an existing L2? And when should I use my own subnet? And this is like, there's no definite answer here, but like I'm gonna give you a few bullet points on what you can consider when thinking about deploying your use case and figuring out if you need layer 2, your own subnet, or mainnet. So the first thing is that mainnet has long finality and high block times, which means that things are gonna be slow in general. And like if you wanna deploy a DeFi use case, it may not be the best option. But on the other hand, it has native storage features. So if you want something storage specific or like that is intensive in storage, maybe you're considering mainnet. For example, like a data DAO or permanent storage, so some kind of auto-renewable storage or so on. These kind of smart contracts that use storage and that are not worried about like performance in terms of like transactions per second, finality, and so on. Just go to mainnet because like the price that you're gonna have to pay for the cross-net interactions, it may be too high when actually you don't need performance from a transaction perspective or transactional perspective. But if what you want is to go fast, like DeFi, any kind of like database or any other use case that is general enough and that we see in EVM and so on, but you need high throughput and fast finality, for that you can use an existing layer 2. Why it's interesting an existing layer 2? Because it has shared security. So you share the security model with all of the other participants in this layer 2. In this case, like Mikhail was touching a bit about mycelium and like this general L2 by all participants. Like the advantage that it has is that potentially it will have a lot of collateral and it will be a shared security model for all of the participants in that subnet. The issue is that it has no custom features. And then we have the case of the deploy your own subnet. When it would be a good idea to deploy your own subnet? When you need custom features. Like for instance, I was saying about this new bundle with specific system actors, the case of Tableland where they want an actor for SQL databases. You want a new consensus that requires a syscall for, I don't know, for randomness or something like that. When you need to really fine-tune the substrate. For these cases, it's better to deploy your own subnet and configure it to the needs of your application. So this is basically like the high level of the needs. And this is the example that we put always, like, you could think of like Filecoin 30-second block times. You could think of the L2 of like general block 1 second block times. And then you could think of like my custom, really optimized subnet to support like data center scale loads or other kind of setups.
Can I have a question on the previous one?
Yes.
So as a user, let's say, can you go back to the previous slide? Yeah. As a user, if developer decided to deploy their own subnet, as a user, how do I know if I should trust the subnet to move money?
So remember that we have this collateral and this proof of stake, and we track the total collateral of a subnet. Usually so we have some simulators to understand like what is the minimum collateral according to the value of the transactions that are going to move. But like the key or the ballpark estimation is that if you see enough collateral according to the value of the transactions that you're planning to operate in your network, there's skin in the game for the validators, and then it's relatively safe to deploy your use case. So you can think of this like when you join any kind of L2. Like you
but what if nobody is running slashers and like if sub-collateral is there, but no.
Of course, without slashers, there's no skin in the game. But like the ballpark estimation is like look at what is the skin in the game for the validators, and like the risk of getting slashed, what are the incentives and so on. This is public because like it's in the subnet actor, in the subnet smart contract, so you can read like what are the rules, and that should give you a sense. But
it seems like we need some form of tools that will show it similar to SSL check in the web browsers that shows like, oh, this site is secure. Like something like this needs to be
definitely
for subnets.
And tooling around reputation, for instance, kind of like we have the SP reputation system, some subnet reputation system, or like L2 beat or something like that, definitely. But the thing, like, I want to note here also that this is a work in progress. Like we're trying to build product now on top of this, which means that there's a lot of tooling and a lot of like UX relationships that we need to figure out. So yeah, and can subnets interact with mainnet? The current features that we have is these basic crossnet primitives that I was mentioning. So it's a way of like sending messages up and down, so you can interact with using like trigger smart contract or like sending funds up and down from a subnet. That is possible. Something that we need to figure out, and this really links with a talk from this morning from Alex, that he was mentioning these rollups for storage and so on, is how to, in a verifiable way, read state from mainnet contracts. Because right now, like you can read state directly from a full node in a contract, but like if a contract from a subnet wants to read state from some other contract somewhere else, this is a mechanic that we haven't figured out, and that it would be really interesting. Like we don't have the feedback loop. You can trigger actions in some other subnet. You can trigger actions in some other smart contract and network, but the feedback is done off-chain. Like you get the feedback through an event in the destination subnet, but you don't get a feedback into the smart contract, which means that this is a primitive that we need to figure out. So you can trigger whatever you want in other subnets, but in order to get the feedback of what happened, you need to listen to event. We don't have a way of doing it in a verifiable way on-chain. And we have ideas of how to do this, but it's not neither implemented or figured out. Yes, and finally, like, how can I decide where to deploy a subnet? This is another interesting question. So my recommendation here is, like we were mentioning, collateral. Like, find a subnet that has enough skin in the game for what you need. Crossnet interactions. So if you're gonna interact with, for instance, I don't know, I'm in root T02, and I usually interact with root T01, T02. It makes no sense to spawn there, because like I would have to pay a lot of overhead for my crossnet interactions. I would have to go to the root and then back to the root T01, and from there on, like, interact with those subnets. So if I'm planning to, for instance, I don't know how to, let's see if this works. Hey, that works. So for instance, I'm this subnet, and I say, hey, I want to spawn from the root because that's the only one I trust, but I have a lot of crossnet interaction. My application really interacts with some service that lives in these subnets. Maybe that's not a great idea, because like what you win in security here, you're paying it in overhead for cross-net interactions. And it may be better to move into roots T01. There's shared security there. Put some additional collateral. Ask your validators to put some additional collateral. And then be here so that the overhead for cross-net interaction is lower. So this is like kind of the mindset that you have to follow. It's a trade-off between security and cross-net interactions. Of course, like being a child from subnet is great because you have a lot of security and you anchor your security to mainnet, but you may be paying a lot in cross-net interactions. So yeah, this is the trade-off that the subnet deployers would have to figure out when they deploy their subnet. And something we are also exploring is the use of ephemeral subnets. So you may have, eventually, as we move into production and we increase the number of features, we will be able to deploy in one subnet and then move to the other one, have ephemeral subnet, deploy subnets from existing states. So the fact that we are content addressed, and that's why we were really obsessed with IPVM and IPLD, is because these primitives are made easy thanks to this. And yeah, like then something that also is worth considering is the performance requirements. So depending on the underlying consensus and the geographical location, we may need to be closer to some nodes or to others. And finally, to give you a sense of what are the features that are pending or like the missing features that we have, we don't have a way of upgrading IPC and subnets. So before we deploy in mainnet, we want to figure out like how upgrades works. Mikhail mentioned slashing. Slashing is in the works, a way of like committing fraud proofs and being able to slash a validator when there's some misbehavior. So we have this designed and we're in the process of implementing it. More complex cross-net interactions. As I was mentioning, right now you can trigger actions in some other subnets, in some other smart contracts, but we don't have the way of getting the feedback or reading state in a verifiable way. This would be way easier with CK primitives, but like CK primitives are not part of IPC yet. The gas model, the fee, and the cross-net interactions are something that is coming also. Like we want subnets to be able to configure their gas model, and also we want to build a clear incentive system and like fee system on top of these cross-net primitives, so that when you deploy an app, you know what you're gonna pay, or you can predict what you're gonna pay in advance, depending on where you deploy your subnet. And we want to have like a lot of, now that we have Fendermint, we want to enable a lot of knobs to allow you customize the blockchain to your needs. And of course, there's a lot of tooling needed. So we need to figure out like multi-subnet explorers, Rust libraries, because right now everything is in Rust, and we expect like the same. So we're building a Rust library similar to Ethers, but in Rust for IPC. It would be great to have also a Web3.js alternative, but for IPC. And there's a lot of UX improvements that one of my goals for the workshop is just to start collecting feedback of ways to improve, and hopefully we can include it in the next release. And yeah, like a lot of these features, maybe they're enabled by the yellow runtime. Like if you haven't watched this talk, to get a sense of what is like, because it felt that IPC has been around for a while, but we had a lot of challenges at the peer implementation, and that's how we realized that this was a need of the yellow runtime. So in order to link like yellow runtime with IPC, I highly recommend watching this talk, and understanding like what are the challenges and the pains of building a peer implementation for any kind of blockchain. And this is, again, I showed it in the yellow runtime, I show it here. This is the dream, like being able to deploy subnet infrastructure as we deploy today Terraform. And it is rough, the UX now. We're trying to improve, and this is the dream, like having a single template that deploys a subnet or determines the topology that you want to deploy. So we're moving, a lot of these features eventually will be moving into this dream that Raul depicted. And yeah, I think that's all for the current state of affairs and like the story of IPC. As I've said, like in a few weeks, we should have now like in testnet, in calibration.net, Fendermint-based subnets so that you can try them. And we're gonna have a workshop afterwards to see a bit what like more of the tech that we currently have. And of course, like let us know if there's a use case that you want us to prioritize over others, like feedback about UX, like anything, like let's trigger a discussion, because like we were really focused on the research and like doing the tech side, and now is the time to start collecting user feedback and figuring out how we can make it useful for the community. So thank you very much, and I don't know if there are any other questions or if I ran out of a lot of time.
Yeah, we a little bit over time, but maybe we can take 2 questions.
There's one here.
Right.
My question is about there is a introduction about the mainnet. If we wanted to use the storage service, you need to go to the mainnet. I talked with Roy about it is possible to subnet the storage and make the storage to the subnet. We can do, leverage the storage service because otherwise we can't build a ritual market in the subnet.
Yeah.
And the storage, for example, boost the service.
Yeah, so this is the current state of affairs. So I focused a lot in the short term, like what is right now, what is the current state of affairs. That's why I mentioned also Alex North talk, because like supporting storage in subnets involves other additional primitives. So it's not only like sending messages. So we could trigger a storage deal theoretically right now. So we could have in subnet and trigger a storage deal in mainnet. But moving storage deals into a subnet would require other primitives that are not like IPC specific. They involve like the proofs, how we do the window post, and like or do we need window post at all? Or we can just have a rollup into the mainnet. So these, in parallel, we will have to figure out all of these primitives, like storage primitives, if we want to support subnet. That's why today, if it's a storage specific use case, let's go to mainnet, because like it would be a mess to do it in a subnet.
Okay, I see. Second question about the fundament. You are building the subnet I can see the subnet-based IPC. I'm curious about the technical architecture about the fundament and Lotus, and there is an agent. The technical architecture between this software.
Yes. So. Yeah. Lotus and Fendermint is what we call like the peer implementation or the client implementation. And it's just the blockchain technology. So with Lotus, we had like this Mir Trantor and then all of the Lotus code base, which is written in Go with its specific networking and so on. And with Fendermint base, what we did is like have a slim, because in Lotus, we were inheriting all that is there for Filecoin. So we had like all the code for Filecoin, much of it. We didn't use it at all because we just wanted a blockchain, but it's there. And with Fendermint, what we're trying to do is a slimmer, lighter client that would allow you also to deploy a subnet with the same kind of characteristics that we were doing in Lotus, but in a way that we can control it and is slimmer, so it's easier to make it reliable. That's like the idea. And then the IPC agent is, so for all of the cross-net interactions and a lot of like these low-level details, they had to, the fact that in Lotus we couldn't change things that could be consensus breaking because of mainnet, we didn't introduce, like the IPC agent had to do a lot of work, background work on, hey, I've seen a crossnet message from the parent, I need to send it to the, like it worked as a relayer. With Fendermint, the relayer operation, it's integrated within the peer implementation because now it's sliders and we can afford like introducing that logic there, which means that we don't need the IPC agent anymore because everything is handled by Fendermint. So all of the, hey, I see a message that needs to be relayed somewhere else, and we need to build a multi-sig for this so that it can be verifiable in some other subnet. So all of these low-level protocols are not handled by the agent because now in Fendermint, we can afford implementing them as part of the client implementation. So that's like the two differences between the Lotus-based setup that we have right now and the Fendermint-based setup, and why we're moving into that one.
Okay, thank you.
Thanks. Any other question? Feedback? Trash talk? Thanks. Thank you, everyone.